students, welcome to our next video. Today we are going to start lesson number 2, which is basics of analytical chemistry. In this chapter we will understand the basic terms, terminology and the basic concepts of analytical chemistry. These concepts, as I have earlier said, that they are important for the entry level students. They will create the foundation of your understanding of the subject. So let us start our lesson number 2. Lesson number 2, basics of analytical chemistry. So in this video, first we are going to learn some fundamental concepts in analytical chemistry. Now, as we know from the previous video what pharmaceutical chemistry was, and we understand that pharmaceutical chemistry is a branch of analytical chemistry. So whenever we are learning about pharmaceutical chemistry, we are actually learning about analytical chemistry. So we need to understand what analytical chemistry is. So analytical chemistry is a branch of chemistry which is focused on the identification and quantification of chemical substances. It means that in analytical chemistry, we are either identifying something or we are quantifying something. Identifying something means that in a sample, if we say that we need to check whether the substance A is present or not, so we are identifying A. We are identifying that is A is present in the sample or not. This is known as identification. Okay. Now in quantification, we already know that A is present in the sample, but in quantification we try to calculate, we try to know the amount of A in the sample. So this is known as quantification. So analytical chemistry deals with identification or the quantification. Quantification is also known as estimation. Now, as you know that analytical chemistry is very important and it plays a crucial role in pharmaceutical analysis, because we know that pharmaceutical analysis is a branch of analytical chemistry. Because this analytical chemistry gives us the tools and methods that we apply in the pharmaceutical analysis, and we perform the analysis of pharmaceutical products. So that is why analytical chemistry is important. Now, there are few important terms that you need to know about the analytical chemistry, or we can say that whenever we are studying analytical chemistry, there are some technical terms that we are going to come across and we must know their definition. So the first definition is analyte. Analyte is something which we are analyzing. It is either a substance or a component which is being analyzed. And what analysis are we doing? We are either performing identification or we are performing quantification. So analyte is a substance which is subjected to the analysis. Like there is an example. See, in pharmaceutical analysis, the drug or the active ingredient is often the analyte. In most of the time, we are either identifying the drug molecule in the sample or we are identifying the amount of that drug molecule present in the pharmaceutical product. Next term is matrix. Matrix is actually the environment in which analyte is present. For example, in tablet, see, we are having a tablet. In tablet, we are not only having the active pharmaceutical ingredient, or we can say that API, it is also having diluent, binder, and other excipients, sweetening agent. So all these components apart from the API is known as the matrix, means the environment in which API is present. So the example says the same thing. It says that key in pharmaceutical formulation, the matrix will include all the excipients and the other components. One more example. For example, we are having a sample of, say, acid HCl. So HCl in that will be our analyte, which we want to analyze. Either we want to identify or we want to quantify. And the rest of the environment will be called its metrics. So in this case, when we are taking an HCl solution, the matrix will be the aqueous environment, all the water and other things or the other impurities present. So this is matrix. Now the next point is calibration. What is calibration? Calibration is the process of establishing a relationship between two things. Number one, response of an analytical instrument, and number two, concentration of the analyte. Now, to make it understand in a very simple language, calibration is actually to check whether our instrument is measuring the correct thing or not, whether our instrument is measuring the thing it is intended to correctly or not. Like for example, you are having a beaker or a measuring cylinder, you can say, and there is 100 ml marking into it. We pour some water, H2O water, up to this brim, up to this mark, and we expect that this is exactly the 100 ml. That means our beaker is measuring the correct volume. So when we are checking whether this beaker is measuring the correct 100 ml or not, then we are calibrating. Calibration simply means whether this beaker is measuring 100 ml or not, and if it is not, then what ml. Calibration is extremely important during analysis, because analysis is based on calculation. If we do not take the right amount, if the instrument is not calibrated, either we will perform some mistake in our experiment, or we will get the wrong result during the experiment. So what is the importance of calibration? The importance of calibration is that it ensures that our quantification or our analysis is accurate and reliable. So that is why calibration is done. Next thing is quantification. And what does quantification means? Quantification simply means to determine the amount of the analyte in the sample. See, if we see the broad classification of analytical chemistry, we say that there are two kinds of analysis. One is qualitative analysis and other is quantitative analysis. Qualitative analysis checks that whether something is present or absent in the sample. But quantitative analysis checks that if something is present, then what is the amount of that thing in the sample. That is the quantitative analysis. So whenever we are performing quantification, we are determining the amount or concentration of the substance in the sample. So there are various analytical techniques for quantification. We are having titration, we are also having chromatography, spectroscopy. So there are many methods which we will deal later on in the module. Now, next term is the standard solution. Now, what is a standard solution? A standard solution is something whose concentration is known to you. This is known as the standard solution. So if you are having a standard solution, then it is clear that you know the concentration of it. So let us see the definition. Standard solutions are solutions with known concentration, and they are used for calibration. So now the and comparison also. Now why do we require a standard? Obviously we require a standard for comparison. Like for example, there is a test known as limit test in pharmacy. In limit test, we are having two Nestler cylinders, two apparatus or two glasswares known as Nestler cylinder, in which we take standard and there is also test in the other one. So there is a turbidity which is produced in both the standard and the test. We compare the turbidity of standard and the test. The turbidity of standard, the concentration of sample in the standard is known and it is compared with the test. So that is why its definition includes comparison. Now, where do we use calibration? In order to calibrate an instrument to check whether it is measuring correctly or not, we need something about which we know clearly. Like we need a solution or the sample whose concentration is known, and we subject it to the instrument and check whether instrument is measuring the concentration correctly or not. So in that way calibration is done. So now, considering the role of standard solution, it is essential for creating calibration curves and ensuring accuracy in the analytical measurements. So standard solutions are very important in pharmaceutical analysis or in analytical chemistry. You are constantly checking the standard solution, you are constantly using the standard solution for your analysis. Now, next term is sensitivity and selectivity. Now, sensitivity is the ability to detect the small changes in concentration. If most of the time we are having either experiment or the instrument. This sensitivity term either we use for the experiment or we use for instrument. We say that this experiment is extremely sensitive, or this instrument is extremely sensitive. When we say that it is sensitive, it simply means that it is capable to detect very small changes, or the small changes you can say. Like for example, there is an instrument called HPLC. This HPLC instrument is more sensitive than normal TLC. HPLC stands for high performance liquid chromatography and TLC stands for thin layer chromatography. HPLC is more sensitive than thin layer chromatography. In the same way, if we want to check the impurity of calcium in water, then the best method to do is by EDTA titration, because complexometric or EDTA titration is extremely sensitive to check these kinds of ions, metal ions. Now coming to selectivity. Selectivity is the ability of an analytical method to distinguish the analyte from other component. Like for example, in a sample we are having substance A, substance B and substance C. And these A, B, C are the three components in the sample. We only want to determine the concentration of A. So if there is any experiment which is determining only the concentration of A, then it would become a selective experiment. So sensitivity and selectivity are the two things which are highly required in pharmaceutical analysis. Coming to the next slide, accuracy and precision. This is an extremely important term. Accuracy means how much the measured value is close to the true or reference value. Let us, for example, there is a person whose actual weight is 50 kilogram, and there is a person A who calculate it as 49.5 kilogram, and there is a person B who calculate it as 48 kilogram. Now if I ask that which person is more close to the true value, true value is the actual weight, this is known as true value, and the weights calculated by A and B are known as experimental value. Now if I ask which person has the value more close to 50 kg, that means the true value, then you will say that A. A has the weight of A is, the weight calculated by A is 49.5 kilogram. So that means A is more accurate. Why A is more accurate? because the value of the experimental value of A is more close to the true value. So that is what accuracy means. Accuracy means how much the measured value, or you can say that the experimental value is close to the true value or the reference value. The more it is closer, the more it will be accurate. For accuracy, the difference between true value and experimental value should be much low as possible. Now coming to the precision, what does precision means? Precision is the degree of reproducibility now or degree of closeness to the repeated measurements. So let us take the above example. The weight of this person was 50 kg. Obviously this was our true value, and there were three persons A, B and C. A calculated its weight as 49.5 kg, B calculated its weight as 48 kg, right, and C calculated the weight as 45 kg. Now if I ask you that whose what these two experimental values are close to each other. See, we are having three experimental values given by A, B and C respectively. Now the question is, I want to know what two experimental values are close to each other. So you will say that A and B are more close to each other. So A and B are known as they are more precise. So precision means the degree of reproducibility. So if you are giving more precise experimental values, then means your experiment is having reproducibility. Precision tells us or indicates the reproducibility of the experiment, whereas accuracy tells us ki how accurate or how good or how specific our experiment is. So this was about accuracy and precision. Now next slide is, we are going to study the analytical techniques in pharmaceutical analysis. So what analytical techniques are? So they are the methods which we are using to obviously analyze and to determine the composition of the substances. And these analytical techniques are very important. We are given pharmaceutical product as a sample, and we are performing these analytical techniques in order to identify or quantify the substances which are present. Why do we use these analytical techniques? As I have told earlier in the previous video, that these techniques are important for the quality control, and these techniques are also important to ensure the safety and efficacy of the drugs. Now, one major important method in analytical chemistry that we use is the titration. We start doing this titration from very early in the pharmaceutical analysis because it creates the fundamental part of analysis. In the older times, analysis usually it contained titrations. Now what titration is? Titration is a technique in which we are performing a reaction between a solution whose concentration is known, and we are performing this chemical reaction with another solution whose concentration has to be determined. We are going to determine the concentration of the analyte. So the substance whose concentration is known as titrant, or it is considered as the standard. The known concentration or the titrant is also called as standard, and the one analyte whose concentration which we are trying to determine is known as titrant. Usually it happens that the titrant or the analyte is taken in the conical flask, right? The analyte is taken in the conical flask, whereas the titrant is usually taken into the burette. So let's repeat this thing again, that titrant is something whose concentration is known and the analyte is something whose concentration is or has to be determined by the help of titrant. We are performing a reaction between titrant and analyte, and by that way we are trying to know the concentration of the analyte. This process is known as titration. So application is that titration is used for, mostly you have heard that it is used for acid base titration reactions, and these reactions are used to determine the drug potency. That means you want to know that in pharmaceutical drug product what is the concentration of the API. That means you are performing the quantification part. Now apart from acid based titration, we are also having complexometric titration, gravimetric titration and argentometric titration, which are used in the pharmaceutical analysis. Now another technique in pharmaceutical analysis is chromatography. Chromatography is basically a physical method of separation, and in this separation technique there are two phases. One is mobile phase, which is moving, and one is stationary phase, which is stationary, which is not moving. Now the substance to be separated is distributed between the mobile phase and stationary phase. Means stationary phase versus mobile phase is happening. So the substance we want to separate, the sample is poured or lodged into the stationary phase, and then we run the mobile phase. And when the mobile phase runs, let us understand with this picture that this is let us imagine that this is stationary phase, and it contains the sample in which there are three components A, B and C. So we will lodge this sample into the stationary phase, and then we will pass the mobile phase. When we will pass the mobile phase, the mobile phase will go from the stationary phase and it will separate A, B and C, and that depends upon the affinity of ABC with the mobile phase. Say obviously when C will travel far, it means that C is having more affinity with the mobile phase and it goes along with the mobile phase, and that's how ABC are separated. So this is the chromatographic technique. So chromatography is a separation technique and it uses a mobile phase, and mobile phase is moving the sample from the stationary phase, and we want to separate the components of the sample, and obviously their separation will be based on their interaction with the stationary phase as well as the mobile phase. So previously, older times, we were using column chromatography, paper chromatography and thin layer chromatography. Even now we are also using them, but these were the traditional techniques of chromatography. Now currently in the industries where we want faster and more sensitive result, we are using sophisticated instrument for chromatography like HPLC instrument, high performance liquid chromatography, gas chromatography instrument, which these are being used. Now the application is, obviously we want to separate and quantify the drug components in the pharmaceutical formulations. That is why we are using an chromatography. Now another kind of analytical technique is spectroscopy. So spectroscopy is simply the interaction of energy and, or you can say that, radiation with the matter. So matter and radiation interact with each other during spectroscopy. There are different kind of radiations. The radiations which we are talking about are electromagnetic radiations. And electromagnetic radiation, the examples of electromagnetic radiations are X-ray, infrared, ultraviolet, radio waves, microwaves, etc., etc. So in this spectroscopy, what we are doing is that we are interacting the electromagnetic radiation with the matter, and it will give us a kind of information, and we will analyze and utilize this information to characterize the substance. Like for example, in UV visible spectroscopy, we perform electronic excitation, and by doing electronic excitation we understand the types of double bond. From infrared spectroscopy we understand the type of bond. From nuclear magnetic resonance spectroscopy we understand the type of proton which is being used. So spectroscopy is nothing but the interaction of electromagnetic radiation and matter, and by this interaction we are getting some information, and this information is used to understand, to quantify, to magnify, to understand, to identify the molecule. Now application is we are determining the structure with spectroscopy, we are determining the purity, we are also determining the concentration of pharmaceutical compounds with spectroscopy. Now next technique is mass spectrometry. See, spectrometry is somewhat different from spectroscopy. In the previous slide you understood about spectroscopy, but spectroscopy a little different from spectrometry. Why? Because in the spectroscopy method the sample which we are analyzing remains intact. There is no distraction to the sample, destruction to the sample remains intact. Whereas in mass spectroscopy the sample which we are using is destroyed, or you can say that it is defragmented into ions. Defragmentation is done. So by defragmentation we get ions. Mostly we are talking about the positively charged ions, and these ions are then separated, and separation is done on the basis of mass to charge ratio. So you can understand this from definition. The mass spectroscopy is a technique which actually measures mass to charge ratio of the ions, and it provides us information. But what kind of information are we getting? See, as we are getting, as you know that we are getting a ratio of mass to the charge. Let us assume that charge is 1 coulomb. So obviously m upon q will be equal to m upon 1. That means you will getting m. That means you can easily find the molecular mass of the compounds, and this can identify, and this can be used to identify a compound. Mostly we are dealing with the organic compounds in mass spectrometry. So mass spectrometry is nothing but a simple way to identify the molecular weight of the compounds. So application is same. If we are having some kind of a known compound, we can easily determine the molecular structure, and even if we are having the known compound, we can check whether our molecule is there or not. Means we want to identify that molecule, we can use mass spectrum. Now coming to the next method, this is electrochemical method. In the electrochemical method, we are using electrical properties to perform the analysis. We are either using voltage or current in order to analyze, means identify or quantify the substance. And the examples of these technique can be potentiometry. In potentiometry we are dealing with the voltage, and in conductometry we are dealing with the conductivity or the electric current, and in polarography we are also using electrical current. So these are different electrochemical methods. Now application is we can analyze the redox reaction by this electrochemical method. We can determine the electroactive species in the pharmaceuticals. Now next technique is again a spectroscopic technique, which is NMR. NMR is a very sophisticated techniques, technique, in NMR technique, we are relying on the nuclear magnetic moments. That means the spin of the nucleus. We are just subjecting our nucleus into an external magnetic field, and in that external magnetic field, we are applying a radio wave, radio frequency RF wave, and then we are checking the spin of the nucleus, and by this information we are identifying the number and types of proton or other active nucleus, spin active nucleus in the sample. So what is the application of this nuclear magnetic resonance? We are using this NMR technique for the structural elucidation of organic molecules. Now coming to the next slide. Now we are studying the analytical instruments which are used in pharmaceutical analysis. Now, what are these analytical instruments? These analytical instruments are actually sophisticated tools which are obviously more precise. They are highly sensitive, more precise, they are performing accurate analysis, and these makes our analysis more sensitive and selective. So obviously they are playing a vital role, and they are helping us to determine the composition, they are helping us to determine the purity and the quality of pharmaceutical products. And there is one more important thing, is that they are doing in a shorter time period. They use less time to perform their process. Now different kind of analytical instruments are there, but as an undergraduate student you must know some of the names. Like first name is high performance liquid chromatography, HPLC instrument. So what is the principle? It will utilize a mobile phase. The principle is same as chromatography. There will be a mobile phase which is passed on, from the stationary phase. But HPLC, the pressure is very high. It is around 150 times the atmospheric pressure. Therefore, method is known as high performance liquid chromatography or HPLC. See, it means that the mobile phase is pressurized, or it is moved under 150 times more pressure than the atmospheric pressure. Now its application, we find it's a very widely used instruments. We find it in the analysis of pharmaceutical compounds and also in the separation of complex mixture. Now there is another instrument called GC, gas chromatography. It is basically used for the volatile compounds. The working is same as chromatography. There will be the mobile phase. Like in HPLC, the mobile phase was liquid, but in gas chromatography, the mobile phase is gas. The sample basically is a volatile. In HPLC, we do not use the volatile substance, but in GC, we use to separate the volatile substance. So the sample specificity is there, and there's an interaction obviously between the sample volatile compound and the gaseous phase, and gas separates the component. The principle is same as chromatography. So we are using the volatile and semi volatile compound analysis by the help of GC. Now then comes the ultraviolet visible spectroscopy. This is spectroscopy or spectrophotometry. Actually photometry is there because it contains the whole UV visible range. So the visible range is from 400 to 800 nanometer, and from 200 to 400 it is the UV. From 400 to 800 it is uh, visible. Okay. So as it is using the complete UV visible range, that is why it is known as UV visible spectrophotometry. Photo word is used for the visible light. Now what we are doing with the UV visible spectroscopy, we are actually measuring the amount of UV light. We are actually applying or subjecting the UV light onto our sample. We are having a sample, and we are subjecting ultraviolet visible light into the sample. The sample will absorb some kind of ultraviolet visible light depending upon its property, and due to that property and due to that amount of light, the range of UV that is being absorbed, we identify this compound. So not only identification but also for quantification this compound is used. The amount of UV absorbed, the amount of UV light absorbed tells us about the concentration of the sample. So now there are two things, qualitative analysis and quantitative analysis. So for qualitative analysis or for identification, we are just checking that what range of UV or what wavelength of UV is absorbed. But for the quantitative application, that means the quantification, we are checking the amount of UV light that is being absorbed, because the amount of, the more the amount of sample present, more the amount of molecule which is absorbing UV light is present, the more UV light will absorb. Obviously it is directly proportional to the concentration of our substance. So we are performing both kind of analysis with the UV visible spectroscopy. So here quantification of pharmaceutical compounds with the UV active functional group. This is the application of UV. Now next technique is infrared spectroscopy. Infrared spectroscopy is simply used to identify the type of bond. In infrared spectroscopy, we just see two atoms connected with a bond like a spring. We consider them as a spring which is constantly compressing and expanding. It is vibrating at its own place. Whenever we add infrared light to this substance, our substance vibration gets increased, and and it will absorb infrared light, and the amount of infrared light absorbed tells us about the type of bond which is present. So what we are doing in infrared spectroscopy, we are measuring the absorption, that means the amount of infrared radiation which is absorbed by the molecule. And obviously there is a change in molecular vibration, because molecule is vibrating, the bond of the molecule is vibrating. When we add infrared light to it, the vibration becomes increased, because infrared is an electromagnetic radiation which is a source of energy. When you will give the energy to a bond, its vibration will increase, and when the vibration will is increase, it will obviously absorb the infrared radiation. And by the type of infrared radiation which is absorbed, we can identify which type of bond is present, and we can identify the structure of the substance. So it is particularly used in the identification of functional group and also the structural analysis. Whenever we are performing the molecular analysis or the structural analysis of a compound, we are using infrared spectroscopy. Now here comes NMR, nuclear magnetic resonance. As I have previously discussed, it is actually telling us about the number and types of proton which is present. So there is an interaction of the nuclear spin with the external magnetic field. As I have already told you, what we will do, that there is a very strong magnetic field in which we will keep our sample. In our sample, the molecule which we are using has a nucleus which is having a spin, and this is spin can be utilized. What we are doing is that we are subjecting radio frequency into the sample. The radio frequency will enter into the sample. It will change the spin of the molecule, and by this time we can identify the type of nucleus present in the sample. So basically most frequently it is used to identify the type of hydrogen, the type of proton present in the molecule. So it will again give us the detailed structural information. It not only gives us the number of proton, it also gives us the number of type of proton present in the sample. So again it is used for the structural elucidation and basically the structure of organic compounds in the sample. Now mass spectrometry, as I have already told, mass spectroscopy is a very important technique. It is measuring the mass to charge ratio, that is M by E ratio. and by this by the help of this mass spectroscopy, we are confirming the molecular mass of the compound. We are confirming the molecular weight of the compound. So obviously it is used to identify, and it is also used to for the quantification technique as well for the pharmaceutical compound. So how we are identifying compound from mass spectrometry? By determining the molecular weight of the compound. Now, next instrument is capillary electrophoresis. Capillary electrophoresis is a very important technique. It uses the concept of electrophoresis, in which we are using two electrode, positive and the negative. The compounds which are charged of the colloidal size will go to the respective electrode that depends on their charge, and that is how we separate the compounds. So what it is written here is it separates the analytes based on their charge. Obviously the positive charge will go to the negative electrode, and the negative charge will go to the positive electrode. They will migrate through the capillary, and there will be an electric field obviously which is applied here, you can see. And due to the influence of the electric field, positive and negative electric field, the positive ion will go to the negative electric field, and the negative ion will go to the positive electric field, and then they will get accumulated into the respective electrode, and we can identify these compounds. So analysis of ions and small molecules can be done by electrophoresis. Now coming to the last technique, which is atomic absorption spectroscopy. Here we are using the concept of absorption spectroscopy. What we are doing here is we are having metal ions. Okay, they will absorb some kind of light, and by the absorption of some kind of light, we check the amount of light which is being absorbed, and we easily calculate the concentration of specific elements present in the sample. So quantification of trace elements is the main criteria that is met by the absorption spectroscopy. Now let us move into the summary of the lesson 2. Our lesson 2, it covered the fundamental concepts of analytical chemistry. We have studied the basic analytical basic terminology like analyte, matrix, calibration. We also understood the analytical techniques such as titration, chromatography and spectroscopy. This is the basic thing. We also understood the importance of calibration, accuracy, precision in the analytical instrument, and we also understand now how analytical chemistry is very important. It is performing a very critical role in the pharmaceutical sciences. Okay, thank you. So I hope you have understood our lesson number 2. Now you know what are the basics of chemical analysis, and I recommend to all of you that you should learn these concepts and try to solve the numerical problems as much as you can. Now our next chapter will be on the sample and the sampling techniques, and we will meet on the next video. Till then, goodbye. Thank you.